So, review of the cheapest full-sized, not mini, not micro, not midi, full-sized metal geared servo I could get on eBay. Yeah, card link. It was $6 or so delivered, not from China, but from within my own country, Germany. And it's a Tower Pro MG946R Digi High Torque. And it's also not the servo I wanted. And yeah, the RC model crowd watching this video will probably laugh their asses off. But that's okay. It was an honest mistake because I didn't even know there are servos that turn 360 degrees left or right, counterclockwise or clockwise, with a speed you can define. I always assumed every servo, you give it some control input and it assumes the corresponding position and stays there. I never heard about these rotating dinghies ever before. Wrong buy, but nevertheless I can review it. So I will check the timing of the PWM signal that's controlling that thing. We will check the angular speed of that thing at different voltages. And of course we will check the current consumption at different voltages. And we will measure the torque that that thing can produce at different voltages, including the current it draws then, which might be quite high. So that's maximum clockwise speed at 1000 microsecond PWM signal. And I'm going down up to 1010, no change. 1020. So full speed clockwise at 1040 microseconds. At 1500 microseconds it stands still. And yeah, 1450 microseconds it stands still. 1440 it's still okay. Other direction, 150 10, 150 40, 150 50, and it starts to move. Full speed counterclockwise at 2000 microsecond signal and 1990. Okay, that took a little bit of experimenting, but I think, max speed is reached at 1930 microseconds. That's the sound of 1920 microseconds. 1930 and 2000 and back to 1920. It's hard to hear, but I guess 1930. It's full speed counterclockwise. Idle current at 3 volts, it's about 5.2 milliamps, and it's supposed to work at 3 volts. Let's try that. No, obviously it's not working at 3 volts. Let's go up with the power a little bit. Okay, at 3.3 barely working, 3.4. And I have to change my amp range here. Oh, maybe it was the... No, 3 volts, it's not working. Yeah, absolute minimum 3.2 volts. And the idle current at 3.2 volts is 3 milliamps. Okay. And it should work up to 7.2 volts. So let's go up to 7.2 volts. And there the idle current is about 4.4 milliamps. Now let's see how much current that thing is drawing. Yeah, without load, full speed at 7.2 volts. So counterclockwise, yeah, let's say 155 milliamps, okay? And clockwise, about the same, 155 milliamps. Full speed, no load at 3.2 volts. Nothing is happening. Oh yeah, there's something happening. Okay. I will have to, rethink the lower voltage that thing is operating on. 3.6 volts seems to be the absolute minimum. And there it's drawing, 95 milliamps clockwise. And interestingly, runs much smoother. 105 milliamps counterclockwise. Well, let's say 110. Just to be complete, idle current at 3.6 volts is 3.6 milliamps. Now for the speed. I will measure the speed at two different voltages, 4.8 volts and 6 volts, because the servo speed is backed at these voltages. And I will count the time I need for 10 full rotations. And clockwise and counterclockwise. And well, let's start. So 1345 and counterclockwise at 6 volts, counterclockwise at 6 volts. We'll compare the things I just measured in the summary with the specs for this servo, but angular speed, at 6 volts, 0.2 seconds for 60 degrees, and at 4.8 volts, depending on clockwise or counterclockwise, between 0.22 and 0.26 seconds for 60 degrees. That's not quite what they promised in the eBay listing. And now for the torque, which is more important than RPMs or rotational speed anyway, as every driver of a diesel car can attest to. I have here a little scale, so we have a display of the force in grams, and I took out not all slack, but most of the slack, and we have our servo here, and hopefully it will all held together. I think the arm here is now 20 millimeters, but I will verify that afterwards with calipers. So let's get measuring. Okay, the ammeters on the side, we are on 6 volts, and there's a little bit of slack here. But if I even touch it, it starts complaining. So let's reset it, and I have to go back to the notebook to, yeah, actually turn the servo. So have fun. Okay, I guess that's enough torture for the servo. I will cut the power now here. And yeah, about-ish. 2000 grams maximum, huh? Okay, same game for 4.8 volts. And yeah, I have to look at the video afterwards to see what the current was. Yeah, 2.5 kilograms. Wow. Let's try that one more time with 4.8 volts. 2.1 kilograms. Okay, I repeat the measurement with 6 volts. 2.3 kilograms. Let's do 6 volts again, yeah. Third time's the charm. Okay, 2.5 kilograms. And once again with 4.8 volts, so we have 3 measurements for both voltages. That was fast, 2.3 kilograms. These torque measurements were sure fun, but we will have to take the results with a grain of salt, because, yeah, I noticed reviewing the video material, our current has been limited by my power supply to 950 milliamps, about-ish. So that's not really the maximum torque we can get out of that thing, what we measured here. Before looking at the summary of the test results, let's take that thing apart and have a look-see if really everything is metal gear inside. So yeah, these are self-tapping screws. So there will be no metal inserts here in the plastic case to hold it together. Just good old cheap Chinese plastic. So, and yeah, indeed, let me zoom down. It's actually all metal gear. Yeah, I thought they might have cheated and only the outer gear was metal, but no, it's all metal gear on the inside. And a look-see at the back side. I mean, you couldn't possibly fit a bigger motor in here. And yeah, that's a power board, 2 small trannies. I think that's some big power MOSFETs. And then there should be some, yeah, here. Voltage regulator, I guess, and the controller chip itself. That's it. To summarize, the PWM timing of that thing is, yeah, quite okay. So counterclockwise full, we had that at 1040 microsecond pulses. And yeah, it stopped completely between 1440 and 1540 microseconds. And counterclockwise full speed at 1930 microseconds. Ideal values being, yeah, 1000 microseconds, 1500 and 2000 microseconds. Idle current, yeah, at 7.2 volts, 4.4 milliamps, at 3.6 volts, 3.6 milliamps. And operating voltage, 3.6 to 7.2 volts. Though 3.6 is the really absolute minimum. I had the feeling that even at 3.6 volts, sometimes it simply wouldn't turn. And so what was in the eBay listing for that thing, 3.0 volts to 7.2 volts, yeah, no, not really. Yeah, Currents at full speed with no loads, yeah, at the 3.6 volts, it was 110 milliamps counterclockwise and 105 milliamps clockwise. Yeah, sometimes the thing behaves differently when turning clockwise versus turning counterclockwise. At 7.2 volts, yeah, maximum specified operating voltage, 155 milliamps. Speed. At 4.8 volts, I got a clockwise maximum speed of 0.22 seconds per 60-degree turn angle. Counterclockwise only 0.26 seconds per 60-degree turn angle. And at 6 volts, it was, yeah, virtually identical, 0.2 seconds per 60 degree. That's not so far off what was in the eBay listing for that thing. That was 0.17 seconds for 60 degrees at 4.8 volts and 0.13 seconds for 60 degrees at 6 volts. The stall torque, yeah, well, my power supply, that thingy here, limited the current at 950 milliamps. So we never got the full torque. But at 950 milliamps, yeah, if you put all the numbers together, we get about 4 kilograms per centimeter to 5 kilograms per centimeter. And advertised for that thing are 13 kilograms per centimeter. Yeah, realistically, you would have to apply 2 to 3 amps to that little servo here to reach that torque. And I'm not sure how long that tiny motor that's in here will survive that. But anyway, it got a lot of torque. To summarize, and meanwhile, I found on the Tower Pro website also a specification for that servo. Yeah, link below in the description. And I won't read out all the values to you, but everybody agrees more or less on the weight. I measured that off camera. And on the dimensions, I measured that also, plus minus a few tenths. I mean, it's a injection molded case, so it depends where exactly you measure. Stall torque, yeah, you can see there are some differences here. I measured 4 to 5 kilograms per centimeter at 1 amp current, and the Tower Pro website says the maximum stall current is indeed 1.2 amps. Yeah. Speed, the eBay values are a little bit optimistic compared to the Tower Pro original values, and I measured even lower values. Operating voltage, again, eBay is a little bit optimistic compared to Tower Pro, and that's what I measured. I'm not sure if the 7.2 volts will kill the servo over time, because Tower Pro says a maximum of 6.6 volts. Temperature range I did not measure, but eBay is more optimistic. Yeah, the deadband 1 microsecond says Tower Pro, and I measured, yeah, 100 microseconds. The thing does nothing between 1440 microseconds and 5014 microseconds pulse length. Idle current 10 milliamp. According to Tower Pro, I measured 3.3, respectively 4.4 milliamps at 3.6, respectively 6 volts. No load currents, yeah, I measured a little bit lower no load currents than Tower Pro specifies. Brings up the question, is that thing sold on eBay really the original Tower Pro servo or not? And just because you saw me using an Arduino to control that thing, here's the code. So I'm using the servo library, and the servo was connected to pin 10. And I have a servo object, and in the setup I just open my serial interface, and yeah, I attach the servo to pin 10, and then in the loop so I don't forget it, I print out enter microseconds for full counterclockwise, not middle position but stop, and full clockwise, and I wait that I input something, and I pass that number in microseconds, and I remove any junk that follows from the serial interface, like new line carriage return. And then I write that microseconds value to the servo. So again, it's a PWM signal that goes to the servo, and I print out in my serial monitor that I just sent that microsecond pulse length PWM signal to the servo. That's all. So that was my review of the cheapest metal-geared full-sized servo, 360-degree servo, on eBay, the MG946R. Bye.